What's up everybody and welcome back to my channel. Do you know what is the difference between a website and a web application? What about a web proxy? Well, in this video you will learn all of this. How to configure them, how to host them, and the difference. So stick with me while we dive deep. So what is a website? A website is a combination of web pages, one or more web pages. And the reason why it is called website, it is because it has static content, meaning it is composed of HTML, CSS, and JavaScript files. So let's start from the beginning. HTML, it stands for Hypertext Markup Language. When a file has .html as a prefix and inside is written some HTML code, well, that is an HTML file. And some of you might not know how to read it, but a software engineer knows exactly what this code will represent on the web browser. Now, you cannot understand it directly, so if you open this file on a code editor, well, you will not understand anything. But the web browser, it is designed specifically, so it will get this code and it will create all the components on the web page. Keep in mind that HTML is like a drawing, so in case you're doing a painting, well, the first step that you need to do is draw what you're going to paint. So HTML is like a drawing. You take the pencil and you draw all the components that you are going to paint later on. So after you finish drawing with HTML, well, you need to paint it. And for that, you need to use CSS, Cascadian Style Sheet. This is a way that you can either do it on an HTML file, but it is a best practice that you keep the style separate from the HTML files and you focus on that file directly only for the styling of your components. So you can use this later on your own projects, or you can even share it with the community. So that is CSS. So let's assume that you finished your drawing and you painted it. Now you want to add some movements on your web page, maybe some sparkles going all around, or maybe you want to integrate a backend service to get some real user data. Well, for that you need JavaScript. JavaScript is used to change the overall HTML page, maybe the components, maybe the CSS also, to change colors, and also to integrate with other endpoints. So you can send API calls using JavaScript to get data or to send data. So let's say we wrote the HTML, CSS, and JavaScript file. Well, the combination of those, we created a web page, and with the web page, we created a website, all with static files. Now, if we want to open it, well, we can go to the file and open it right away. So, hello Sty, you are awesome. Bye. Now, how can you share it with your colleagues or your friends? Well, you cannot just give the URL to your colleagues. Why? Because this URL is particular to your local host, meaning your computer or your laptop. So your colleague has no idea that this file or this path exists. So what can you do? Well, you can zip the entire folder into a zip file and send to your colleague. He can unzip it and then open. But that is not how things are done here. What we're going to do is start a web server. What is a web server? Well, a web server is any server that is able to communicate through HTTP protocol. So in a server, you install HTTP web server software, and that software is going to make this server able to communicate with this protocol. Now, if you Google this term, HTTP web server software, well, a lot will come out on the Google, but most popular is Apache and also Nginx. So Apache is a web server software, but also it has a lot of features that we're going to see through the video, and that makes us able to publish our website. Not only with this software, but also we can use programming languages. For example, we can use Python to enable our localhost to be able as a server. So if we go to the folder where our website stands, so cd 01 website, we can write python -m http.server --directory right in here and port 8080. So right now we just opened a web server in our local host. Now, as you can see, it works perfectly great. This was before, this is now with an IP address, or we can go localhost port 8080, which works. Now, you cannot just give this IP address or hostname to your colleague. Why? Because it has no idea. And here is why. Now, uh, if we see into this diagram, what we have our home network. So I'm at my home. I am connected with a wireless on my Wi-Fi router, which is the main router. And I have maybe this private IP address, which is 192.168.0.101 on port 8080. So if I give this address to my colleague, which can be across the state, well, he will not be able to connect with it because that is a private IP address. Even if I write in Google and say who is my IP address and it will come like this maybe, well, still it will not work. Why? Because this does not correspond to this IP address on private network. So for that, I need to do some port forwarding on the router, which is quite complex and not everyone can do it. Now, but if I give my IP address, my private IP address to my brother's laptop, which can be in the same network as my home router, well, he will be able to go to the web browser, search this IP and the port, and this website will open on his web browser. So that is the reason why you cannot just give this IP address to your colleagues or to your friends outside of your local network. Now, so what can you do? Well, for that, you need a public web server. A server which enables HTTP communication and it has a public IP address. How can we get one? Well, we can get a public web server to the cloud provider. So we can go to AWS or Microsoft or Google Cloud, anything that provides you with a public server. So let's get going. On the console, we need to launch a new instance. We call it web. We're going to specify Ubuntu as the image. Let's make it a little on T2 medium. We do not want a key pair to connect with it. Let's change the subnet to US East 1A. The assigned public IP address is enabled. Now we need to also enable HTTP from anywhere because we want to connect with it. Add some gigabyte of storage, and we are going to add some user data just to make things faster. So this is my user data, and we can launch the instance. Now, what is this user data going to do? First of all, let's stop the Python application that was running. Now, this user data, basically it installs Apache and unzip. It collects a zip file from a S3 bucket that I have already uploaded just for the front end and gets this front end and runs the Apache. So here is what is going to deploy. So this is the server, this is me. We have the website files, so all the files for the front end, so HTML, CSS, and JavaScript files are saved on /var/www/html folder, and Apache is configured by default that when it is run, it will expose this port 80 and all the requests are going to get those files in here. So if we go to the instance that we just deployed and we get its public IP address, we can see that the website is up and running on this public IP address. Now, let's say you finished your website and you want to add the new feature to your website. So maybe you want to do some business logic behind, or maybe some computation, or you want to save some data that you want to use later on, or to get some data. Well, for that, you need a backend. Now, when you add a backend, you make your website transform to a web application. That is the difference. So a website is a static web page, while a web application, it is a dynamic one, meaning that you insert some computation on the background. Now, when you architect a web application, you need to think whether or not you want to keep them both as one or you want to separate them. What do I mean by that? So in case you are programming with Python Flask, for example, you can either create templates on HTML and you can use Flask to render out those templates to the user. This is called two-in-one, so frontend and backend is working as one. Maybe some PHP code also works like that. Most of the PHP code works like that. And for the newer technologies, for example, React, well, that the front end and the back end is separate. So the front end can be with React and the back end can be any kind of backend languages that there is possibly can. So maybe it can be Node.js, for example. So that is something that when you design an application, you need to think of. So I created a backend that it is for getting quotes. Right now, since I deployed only the front end, it does not work. So we are going to change it. Now, if we connect with our website, first of all, let's go to Route 53 because we need a domain name for that. Let's see the hosted zone and add this instance as the target. We need web, and this is the target. Now, we can connect with this instance. We can go to the web app. Let's get the script. I will explain later what this script does. Nano script.h, paste it. We change location of the script and we run it. And also I need this other domain in here. So while it runs, it will install some things. And this is what is going to happen in the end. So what do we have here? We have the same server, and right now we have added the Python application. It is a Python application run in Flask framework, and what it does, it exposes only one path, which is get quote on port 5000. It is the same server, and what is changed, it is only the Python application. So this Python application, it is for get quote. So anytime you make a request on get quote path on port 5000, well, this Python application will provide you with a random quote. Maybe you can save this in a database, or I have saved it on the application itself. Now, on the Apache, I have configured it in two paths. So the default path is going to be that all the requests are going to be sent to the website files. And for all the requests on /API, which means that you are incorporating a backend, well, all the requests of /API are going to be sent on the local host on port 5000, meaning that it will go and get the method on the Python application. So it has finished, and we can open this domain on the website, on the web browser, and see what is going to happen. So it is the same as before, but we can get quotes now. So the quote is running. Why? Because we started the backend application on Python, and you have no idea what goes on the server. Why? Because what the web browser does is just it sends the same API request just on the domain name, which is the server itself, but you do not know that there is a port 5000 open on the server that is running the backend. So all the requests are going through Apache service. It can either be in one server, or you can have a particular server hosting Apache by itself. Now, as you saw through the video, Apache is used as a web server, but also we managed it to be as a routing. Why is that? Because Apache is a web proxy. A web proxy is like a front door for your web applications, and it takes all the hits, so all the requests are going through it, and based on some routing policies, it will forward the traffic to the endpoint, to the front end, to the back end. Maybe you have some more backends, so you have a lot of backend servers. Well, that is going to play the role of a load balancer. Now, when you architect this kind of application, you can either specify that all the services be in one server, as it is right now, or you can specify them to have their own server. What does that mean? So, well, you can have your Apache service running as a web proxy or as a load balancer inside an EC2 instance, which is on a public subnet. and all your application will be on different EC2 instances. So the front end will be in another EC2 instance and the backend will be in some other EC2 instances, and all the requests are going through Apache's server. After that, it is going to route the traffic to the private network. So that is what we are going to see right now. We're going to deploy the entire application that we just deployed, but in different servers. So let's get going. And for that, we need one EC2 instance for the front end, one for the Apache itself, and 3 backend services that we're going to do a load balancing on them. So let's go to the code editor. I have already created some Terraform script for that, so we can go to web proxy infrastructure, Terraform init, Terraform apply, auto approve. We need also the domain name that we want this Apache to front. And while this is running, let's see the diagram that we're going to deploy. So, as you can see, we are going to deploy a VPC. Inside of it, a public subnet, private subnet. We will have one EC2 instance working as a load balancer, and inside of it, it is Apache with some configurations. And the other EC2 instances for first the front end, which still runs Apache inside as a web server, and 3 backend servers that are running our Python application in it. And those backend servers are exposing port 5000, and all of them are on private subnet. What does that mean? It means that I am outside of the VPC network, I cannot connect with them directly. Therefore, I need this load balancer, the Apache server, that is on the public subnet. Now, on the Apache server, I have already configured the Apache configuration file. So all the requests on path / is going to go to the front end, and all the requests on /API it's going to be loaded into all the IP addresses of our EC2 instances that are hosting our backend applications. Let's see if it is running. Now, since Terraform has finished, we can get the Apache IP address. And we need to add a route into this IP address. So as we called website, we make value, create records, and we get this URL and open it. Now, it works, and the get quotes also work. Now, what happened in the background is that we created our instances. So we have 3 backend instances, 1 frontend and 1 proxy. So, all of them are on private subnet, so as you can see, they do not have a public IP address, but our proxy has. And if we see our proxy configuration, we can see that it has already created a load balancing configuration for all of our backend IP addresses, which are on port 5000. And also the routing, so in /API, it's going to send it on the backend cluster, and / it is going to send it on our frontend IP address, which is on a private IP address. Now, since everything works, we can see that our web application works. Now, you provide this to your colleague and your friend, and they say, you know what, it is not secure. Why? Because this key right here says that connection is not secure. So what we are going to do now? Well, there is also a solution for that. To enable security, it's not quite complex. It's very easy, in fact, and it is free. So since we have the domain available, we can go to certbot. In here, you need to specify how is your application running. So it is using Apache and it is on Linux, and we're going to use pip to install it. The certbot will provide you with all the commands that you need to run on the server. So it will enable SSL, so HTTPS. We can connect it with directly. While we connect with it. Okay, run commands. Yes. We need to create the Python virtual environment. And installed certbot. It's very straightforward, right? We prepare the certbot command and we run it. So we need an email address. So ustai@ustai.net. We specify yes, yes, and it says for which domain you want to enable SSL. So we can just specify for the one, which is the website one. And we wait. And what certbot is actually doing is creating some private key and full chain certificates, saving it and also creating this proxy SSL configuration, which is the same as our Apache configuration that we have already in here, but it also has added some SSL configuration in it. So if we go back to the website itself and we reload the website, we see that it is secure. So we enabled SSL. So we made our website web application using HTTPS protocol. And it still works since our application is up and running. Recap time. So as you can see, we managed to do a lot in this video. We found out what a website is, what is the difference between a website and a web application, how to host them, how to make them public, what a web server is, what a web proxy is, how to configure a load balancer, how to deploy the entire infrastructure with Terraform, and also how to enable SSL or HTTPS on our web application. We did a lot and it was so easy. Now, when you think about EC2 instances and servers, well, keep in mind cost. So each cloud provider has their own cost for the server that you run. So make sure that you destroy them after you have your hands dirty. Now, in case you want to see another option on how to host your web application, not only the website, because website you can host it directly to S3 buckets as a website on there, but you can even host web applications, especially those that are small, into Lambdas. Well, I will link to this video. In this video, you'll learn how to deploy your web application on Flask or any other framework into Lambdas, so you will have zero cost. And I hope you enjoyed this video and have a nice day.